All right, assalamu alaikum everyone. Let's start. So we have talked about how to integrate simple functions like these and also how to integrate fractions. There were a number of different methods for integrating fractions that we have done in the last few days. All right, now today we are going to move on and discuss how to integrate products. So if we have a product, how do we integrate that product? That is what we want to do today. All right. Now there's a specific name for what we're doing, and it's called integration by parts. You can also call this the product rule of integration. Right, so sort of equivalent to the product rule of differentiation that we used to have for integration. The product rule that we have, we call this integration by parts. This is what we want to do today. All right, let me just start this other session as well. Just give me a minute. All right, so it's working now. So we want to see. Okay, so we want to do how to integrate products in this particular part of integration of this topic. Let's say we have something like this. We want to integrate x e raised to power 2x. Now, this is a product, right? We have two expressions being multiplied. Now, how would we integrate this? Integral of x is x squared over 2. Integral of e power 2x, that's e power 2x over 2. However, these are actually multiplying here. It's a product. These are not separate terms. We can't integrate them separately like this. It won't work like this. Just like in differentiation, if we had two things being multiplied, we could not just differentiate them separately. We had to use the product rule that used to look like this: uv dash plus vu dash. So for the same reason, we can't integrate like this either. If we had a sum here instead, so if we had, for instance, integral of x plus e power 2x, we could integrate these two expressions separately. But if it's a product, it's one single term. We can't integrate those two expressions separately. We need some proper way of integrating products that we will be using here. All right. So how do we integrate products like this? That's what we want to do today. Now, if you look at the formula sheet, we have done all of these different methods that you have in the formula sheet. We've discussed all of these. And we have also discussed this method that's written at the end here. This is the log rule that we have. There's just one thing left, and that's this formula that's written here. You can just copy this. This is called integration by parts. This is called integration by parts, and this is what we will be using to integrate products. This is what we're going to be using to integrate products. Okay. Now, how do we use this formula? Let's try to think about this. So how it works is we have two expressions on the left side here in our integral. So in the original integral that we have above, one expression is x and the other is e raised to power 2x, right? These are the two expressions that we have here. In the formula that we have u multiplied by dv over dx, and we want to integrate this with respect to x. So what we do is, these two expressions that we have here, we say, let's assume one of them to be u and the other to be dv over dx. All right. So we assume one of them to be u here and the other to be dv over dx. Now let's say, if we were to say that u is equal to x here. So in place of u, we've got x, and in place of dv over dx, we have e raised to power 2x. Then all we have to do is, we have to write the integral of this is going to look like this: u into v minus integral of v into du over dx. Now, how does that work? Let me write that integral here first of all. That's x e raised to power 2x. We want to integrate this with respect to x. What we're saying is u is x and dv over dx is e raised to power 2x. Okay, this is what we have right now. Now, on the right side of this formula, we have u, v, and du over dx. We need to figure these things out first of all before we can use this formula. So this is what we want to integrate: x into e raised to power 2x. What we do is we say, let's assume the first expression to be u and the second to be dv over dx for now. Okay. Now, if we do this, what do we have on the right side of this formula? We need u, v, and du over dx. Now, what do we do for that? We know that u is equal to x. We differentiate it to find du over dx because we need to put that on the right side here. We need to put du over dx here. We know that u is x. We find du over dx. Let's see what that turns out to be. The derivative of x with respect to x, that's just 1. And the second thing that we need is v. We have dv over dx. How do we go from dv over dx to v? We have to integrate. So in order to go from u to du over dx, we had to differentiate. In order to go from dv over dx, we have to integrate. So let's integrate this with respect to x. That would give us v. What's the integral of e raised to power 2x? Integral of e power something is just e power that thing. And then we divide by the derivative of this expression. That is 2. That is what v is in this case. All you have to do now is input these values of u, v, and du over dx in this formula. How does that work? Let's just input them here and see what we get from that. We have u into v. What's u? U is x. Let's put x here. Into v. V is e raised to power 2x over 2. Let's put that here. E raised to power 2x divided by 2. So that's this first part. All right. Subtract from this integral of v. Again, what's v? V is e raised to power 2x over 2. Let's put that here. E raised to power 2x over 2. Multiplied by du over dx, which is 1 into dx. Now, let's simplify this. It becomes 1 over 2 into e raised to power 1 over 2 into x e raised to power 2x minus integral of 1 over 2 into e raised to power 2x with respect to x. Now you see, once we have done one step of this, the integral that you have now becomes much simpler. We had a product earlier, x multiplied by e raised to power 2x. Now it's just a simple integral of e power 2x. And this is something that we can integrate directly. 1 over 2 is just a constant. We could also just write it outside the integral if we wanted. All we have to do is integrate this part. Okay, let's do that. That gives you 1 over 2 into x e raised to power 2x minus 1 over 2. This number stays as it is. What's the derivative of e power 2x? It's e raised to power 2x divided by 2. Simplify this and you get 1 over 2 into x e raised to power 2x minus 1 over 4 into e raised to power 2x plus c. And that is the integration of this expression. That's the integration of this expression here. So what we do is, we would have a product given like this, right? We're going to assume one of them to be u and the other to be dv over dx. That's how it's written in the formula sheet, right? So the first one we assume to be u, the second one we assume to be dv over dx. We will learn in a while how do we decide which one to take as u and which one to take as dv over dx, because right now we're just taking x as u. What if we took e power 2x as u? We will learn how to choose between the two. However, you choose one of them as u and the other as dv over dx. Write them on the side here. From u, you find the derivative of u, which is 1. From dv over dx, you find the integral of that, which is v. And then you just input values in the formula. Integrate, and that gives you the result at the end. Okay. Now, you might think it's a very weird way of writing this formula, right? U into dv over dx. In product rule, you just used to call those expressions u and v, but here we are calling them u into dv over dx, right? Now, the reason for that is it's actually coming from the product rule of differentiation. So let me actually just explain where you get it from. So remember the product rule of differentiation. This is how it used to work. The derivative of u into v, what's that? How did you used to differentiate u times v? It was a product. The derivative of this was u as it is, and then dv over dx, right? Plus v as it is into du over dx. That was the product rule of differentiation. Now, the product rule for integration actually comes from this same background. What we do is we say, let's integrate this whole expression. If we were to integrate this whole expression, what would we get from that? If we integrate both sides, so we integrate the whole expression with respect to x, that gives us d over dx of uv with respect to x. On the other side, we would have integral of u into dv over dx with respect to x plus integral of v into du over dx with respect to x, right? Now, on the left side, we have integration with respect to x. So integration with respect to x and differentiation with respect to x. They cancel each other's effect and we're just left with u into v on the left side. On the right side, we have u into dv over dx with respect to x, integral of that, and v into du over dx, integral of that with respect to x. Now, if I were to make this the subject, it would give me integral of, in fact, this the subject. If I make this the subject, it gives me u into dv over dx with respect to x, integral of this, that is equal to u into v minus integral of v du over dx with respect to x. And that's exactly what the integration by parts formula is. So it actually comes from this differentiation notation. So from the product rule of differentiation, if we just integrate the whole expression and rearrange it, we get this integration by parts formula, u into dv over dx, integral of that. That's equal to u times v minus integral of v into du over dx with respect to x. Now, one of these expressions is u and the other is dv over dx. So since it comes from that product rule of differentiation, you sometimes write it in this form, and this is the form that is given in the formula sheet. This is how they give it in the formula sheet. All right. There's also another form for this, in which you write it as u times v, integral of that. But in that case, you would have to memorize the formula because they will not give you that in the formula sheet. So I would recommend that you use this form that's given in the formula sheet because it's safer in the sense that even if you forget, you have the formula sheet to basically you have the formula sheet as a backup in case you forget. If you use the other formula, if you're used to using the other formula, there's another form for this as well. You'll have to memorize that. Okay, so I would recommend that you just use this formula. It's given in the formula sheet. You just have to input values. Just understand what you're going to do is you're going to take one expression as u and the other as dv over dx. That is what you're going to do. Okay. Now let's take a few examples to try and understand this better, how to use this formula. Okay, let's take another example. Let's say now we have something in this form. So we want to integrate, for instance, we want to integrate x into cos of 5x. We want to integrate this with respect to x. Now, how do we do this? Let me just copy the formula. It's given in the formula sheet. So you have this in front. This is how it looks. You say x is u and cos of 5x is dv over dx. Okay, again, for now, just trust me. This is what we're going to use as u, and this is what we're going to use as dv over dx. We'll learn how to choose between the two. For now, I'm just saying u is x and dv over dx is cos of 5x. Let's write that down on the side here. U is x and dv over dx is cos of 5x. Now from u, you need to figure out du over dx. And from dv over dx, you need to figure out v. So u needs to be differentiated and dv over dx needs to be integrated. What's the derivative of x? It's 1. So du over dx is just 1. What about the integral of this? Integral of cos is sine. So cos is going to convert to sine. It becomes sine of 5x. But then you have to divide by the derivative of this part. What's the derivative of 5x? It's 5. You divide by 5 here. Okay, remember we can only do this when the part inside is linear. It is linear in this case. So we can just apply this simple rule like this. And now all we have to do is input values in the formula. The integration that we want to do looks like this: x into cos of 5x with respect to x. This is what we want to integrate. What is this integral going to be? U into v. What's u? U is x. Let's write that here. Into v. V is sine 5x over 5. Let's write that here as well. Sine of 5x over 5. Minus integral of v. V is sine 5x over 5 into du over dx, which is 1 with respect to x. Now we have 1 over 5 into x into sine of 5x here already. And now we need to integrate this part. We could write the constant outside. The constant is being divided. You can just write that outside like this. We can say this is 1 over 5 into integral of sine of 5x with respect to x. You could also keep 1 over 5 inside. It doesn't matter because 1 over 5 is just going to remain 1 over 5 even after integration because it's multiplying with this. So the constant that is multiplying with an integral, that stays as it is. Let's integrate that part now. 1 over 5 into x into sine of 5x. We have minus 1 over 5 here. What's the integral of sine 5x? Integral of sine is minus cos. So it becomes minus cos of 5x. And then you divide by the derivative of this part, which is 5. All right. Now you could simplify this, and that gives you 1 over 5 into x into sine of 5x plus 1 over 25 into cos of 5x plus c, and that is your integral. That's the integration of this thing. All right. Let's move on. Let's move on and do another integration. Now, let's say we have an integral like this. Integral of e raised to power 2x into u, sorry, 2x into x with respect to x. Now, if you remember, this is actually very similar to, in fact, it's the same integral that we did earlier. The first example, x into e raised to power 2x, but now I've written in this form, e raised to power 2x multiplied by x. Now I've written this like this, okay? Now, what's the formula? This is what the formula is. Let's apply this formula here and see what we get from this. Now, what we've been doing until now is we were choosing whatever was the first expression as u. Okay, so let's choose this as u. And whatever was the second expression as dv over dx, so let's choose this as dv over dx. All right, so we're choosing the first expression as u and the second as dv over dx. That's what we've been doing until now. All right, let's do the same thing here. Now, if u is equal to e raised to power 2x and dv over dx is equal to x, what we need to find is du over dx first of all. So let's differentiate it. So you have to find the derivative of u, du over dx. What is that? E raised to power 2x. What's the derivative of this? It's just e raised to power 2x multiplied by the derivative of this thing, which is 2. So the derivative of e power 2x is 2e raised to power 2x. That's du over dx. All right. And then you have to integrate this thing. Integral of dv over dx. How do you integrate it? We have to find v, right? So for that, we have to integrate this. Integral of x is x square, increase the power by 1 and divide by that increased power, x square over 2. Let's input those values here. So the integral that we were trying to evaluate there was e raised to power 2x into x with respect to x. Let's input values. U into v. What's u? U is e raised to power 2x into v, which is x square over 2. All right, that's okay. Minus integral of v, v is x square over 2, multiplied by du over dx, which is 2e raised to power 2x. And now we need to integrate this thing. Let's simplify this. This gives us 1 over 2 into x squared into e raised to power 2x. I've just rearranged this. 1 over 2 I've written separately. Then you have x squared, or let's not confuse you here because that's not the point. Let's just keep it as it is. E raised to power 2x into x squared divided by 2. That's what you have in the first expression. Now 2 and 2 get cancelled here. What are we left with? We have integral of x squared into e raised to power 2x. Well, it's again a product. And the problem is it's actually even more complicated than the original product. In the original product, you had x power 1 and e power 2x. Now you have x squared with e raised to power 2x. And this is even more complicated than before, right? So we started from x e raised to power 2x. Now we have x squared e raised to power 2x. Now, what do we do with this? We could apply integration by parts here again, but we did not used to do that earlier. in the earlier example, in the same example, when we chose x as u and e power 2x is dv over dx, we could integrate that directly. But now we can't do that, right? Because now we have another product inside this integral, and that's even more complicated than the first integral. So there's a problem, right? And the problem is we have chosen the wrong term as u here. We should not have chosen e raised to power 2x as u. That is what is causing problems here. So that takes us to this point that it's important, it's significant to understand which term, which expression you're going to choose as u and which expression you're going to choose as dv over dx. All right. So what exactly is the problem here? In the earlier example, in the first example that we did above, what was happening was when we differentiated x, so when we took x as u, du over dx, the derivative of u, actually became something simpler, right? The derivative of x became something simpler. X was reduced to just 1, right? In this example, we had u as e raised to power 2x. When we differentiated it, it did not really become simple at all. It remained the same, e power 2x. All right. So what we want is that when we differentiate u, it should become something simpler. It should become something simpler. Otherwise, we would have a problem. Okay. That's one thing. And the other thing is dv over dx is something that we're actually integrating. Now here, that's not a problem, but sometimes you end up getting some functions that you do not know how to integrate directly. For example, let me give you this example. Let's say you have ln of x into, or let me write it the other way around. Let's say you have sine of x into ln of x. Let's say you want to integrate this. Now, in this case, if you choose ln x as dv over dx, so if you choose, let's say, sine x as u and ln x as dv over dx, you would have u equal to sine x, and du over dx would become cos x there, which is okay. Although it's not getting very simple, so that's a problem, but we can still differentiate it. However, dv over dx is ln x. We have to integrate it. We do not even know how to integrate ln x, right? Ln x can't be integrated directly. We don't know how to do that. So sometimes you end up getting an expression that cannot be integrated. So if you choose that as dv over dx, that is also going to be a problem, because if you can't integrate dv over dx, you can't use this formula. So when you are choosing u and dv over dx, you have to keep two things in mind. There are two things that you have to keep in mind. So that's the logic, basically, that you should understand here, first of all. When you're using this formula for integration by parts, how do you choose u and v? Let me write down a heading here as well. Choosing u and dv over dx. The first thing that you should keep in mind is that dv over dx should be something that you can integrate directly. So if you end up getting an expression that cannot be integrated, you cannot take that as dv over dx, because then you would not be able to find v from that. dv over dx should be something that you can integrate directly. That's important. Okay, that's the first thing that you need to keep in mind. And then U should be something U should be something so if both expressions can be integrated, then you look at the second rule. If there's one expression that cannot even be integrated, then you have to choose that as B. Then you don't have a choice. But if both can be integrated, so the second condition is only if the first condition does not help you decide between the two. If both expressions can be integrated, for example, in this case, e power 2x can be integrated and x can also be integrated. If both can be integrated, you can write that here. If both expressions can be integrated, the ones that you have in the product, if both of them can be integrated, in that case, U should be something you should be the one that becomes simpler after differentiation. Remember, U has to be differentiated. U has to be differentiated to find du over dx, right? So U should be something that becomes simpler after differentiation. Why is that important? Because otherwise, since you have du over dx here inside this integral, if it doesn't become simpler, your next integration is going to be even more complicated, which is what happened here to us. E power 2x was not becoming any simpler after differentiation. E power 2x, the derivative of that gave us 2 e raised to power 2x. That was not any simpler than the original function. On the other hand, if you chose x as du over dx, it would have given you just 1, and that would have been simpler than the original expression. All right. So that's how you decide between dv over dx and u. How do you choose between the two? dv over dx should be something that you can directly integrate, and u should be something that becomes simpler after differentiation. All right. However, there is actually a rule, there's actually a thumb rule that you can keep in mind, where you would not have to where you would not have to think a lot. You can just use that thumb rule to decide directly that okay, this is what you should take as u, and this is what you should take as dv over dx. Now let me write that rule down here, but that uses the same logic. This is the logic, but now when you are integrating, you can actually keep this rule in front of you, and this is how it looks like. You have this sequence of letters I, L, A, T, E. All right, you can remember this as I late. Okay, you could remember this set of letters I, L, A, T, E like this in this order. Now, in this set of letters, I represents inverse trigonometric function. I represents inverse trigonometric function, of which you have only one in your syllabus, which is tan inverse. Right? Inverse trig function, you only have tan inverse in your syllabus. Okay, that's I. Then you have L. L stands for log. So you could have ln here. All right, that stands for log. Then A stands for algebraic expression. A stands for algebraic expression. That means something in terms of x. So maybe x or x square, or sometimes just a constant as well. We will see sometimes you have to use a constant. You could write that x power 0, that is x power 0, but something in terms of x like this. That's algebraic, okay? T stands for trigonometric function. For example, you could have sine, cos, tan, not tan in fact, generally sine, cos, and secant square, for which you know the direct integrals, right? You know how to integrate sine directly, you know how to integrate cos directly, you know how to integrate secant square directly. You could have one of those. And then E stands for exponential. That means e raised to power something. These are the five different functions that you would have here. Now, what you'll do is you'll just remember this sequence of letters, and now you are going to have two of these functions at a time, okay? So in example that we did earlier, x e raised to power 2x, or we could also write it as e power 2x into x. Now, how do we decide which one to take as u and which one to take as dv over dx? You will see which two functions you have. E power 2x, that's an exponential function. So that's e here, right? And x is an algebraic function. That's a here. Now, in this sequence, whatever is coming on the left side, you choose that as, you take that as u, and whatever is coming on the right side, you take that as dv over dx. Okay, so now you can just remember this. I you'll have two of these five expressions. Of the two that you have, you still have two of these expressions, right? Of those two, whatever comes on the left side, so among A and E, for instance, A is on the left, you take A as U and E as dV over dx. That's how you decide. And it uses the same logic that we wrote above, because tan inverse trigonometric function, we can't integrate them directly. So that's why, no, I'm sorry. Yeah, so we can't integrate them directly. Since we can't integrate this directly, it has to be u. It can't be dv over dx, right? Similarly, we do not know how to integrate log directly. That also should be u. All right. So these two kind of have the same priority. So they won't come together in an integral. Only one of them will come, and the one of the other will be of these other three options. Okay. So I and L, normally they have to be U. All right. And then amongst the other three functions which can be integrated, A is the function, algebraic function is the one that becomes simpler when differentiating. So if you have an A, and along with that, you have one of these other functions, you should take A as U, because algebraic would become simpler after differentiation. So this should be U. Trigonometric functions and exponential functions, on the other hand, they don't become simple. For example, sine becomes cos when differentiated, cos becomes sine. So they don't really become much simpler. E power something remains e power that. So these are two functions which don't become simpler. So we generally take them as dv over dx, right? So normally algebraic function can be taken as both u or dv over dx, depending on what the other function is. If the other function is log and one is algebraic, then you would say take L as u and A as dv over dx. So whatever comes on the left, that is u. Whatever comes on the right, that is dv over dx. That's how we decide when we're using integration by parts. All right. So remember this, I whatever comes on the left is u, whatever comes on the right is dv over dx. Now, let's take an example and use this rule now, I to see how we can integrate this. So for instance, if you want to integrate x into ln of x with respect to x. How do we integrate this? Let me write down that formula here, copy that formula here. This is what the integration by parts formula looks like. We need to decide, first of all, which of these two to take as u and which to take as dv over dx. That's the first decision that we have to make. We can use IL8 for this. ILATE. Whatever comes on the left is u, whatever comes on the right is dv over dx. Now, which two expressions do we have? We have algebraic and logarithmic. We have log and algebraic. So that means log is going to be u and algebraic is going to be dv over dx, because amongst these two, algebraic is coming on the right side and log is coming on the left side. So in this case, we should be taking log as u and x as dv over dx. All right, so let me just present that here. U should be ln of x and dv over dx should be x here. All right, so that's what we will need to do here. Now let's write those two things on the side here. U is equal to ln of x, right? U has to be this one. And dv over dx should be x. Now, in order to use this formula, we need du over dx, the derivative of this thing, and v, which is the integral of this thing. Let's write those things down on the side here. We need du over dx, and we also need v from this. What's the derivative of ln x? Remember that? Derivative of ln x, that's 1 over x. So du over dx here would be 1 over x. What is the integral of x here? Because that's going to be v. You increase the power by 1, so it becomes x squared divided by 2, that is v. Now you just have to input these values in this formula and you get the result. So let's do that. The integration that we want to do is x into ln of x with respect to x. That's the left part here. On the right side, we have u times v. What's u? U is ln x. Multiplied by v, v is x squared over 2. All right, that's u into v. Minus integral of v, which is x squared over 2, into du over dx, which is 1 over x. That's being multiplied here. And we need to integrate this thing with respect to x now. Let's simplify this. This gives us 1 over 2 into x squared into ln of x. Subtract from this. So if we cancel this out, it becomes just x. And we have 2 here. So we could write this as integral of 1 over 2 times x with respect to x. We could also write this 1 over 2 outside if we wanted. So you can do that if you want, or you can leave it inside. That's your choice. Let's integrate this now. It becomes 1 over 2 x squared into ln of x outside. That remains as it is. We have already integrated that. Then you have minus 1 over 2 as it is. What's the integral of x? It's x squared over 2. Let's simplify this. It becomes 1 over 2 into x squared times ln x minus 1 over 4 into x squared plus c, and that's your integration. All right, so that's how we use integration by parts like this. Make sense? Let's move on. Let's take another example. Now, it's going to become slightly more complicated now, gradually. Let's say we want to integrate x squared into e raised to power 4x with respect to x. This is what we want to integrate now. Let me copy the formula. This is what the formula looks like. Now, first of all, we need to decide which of these two expressions to take as u and which to take as dv over dx. Let's use ILATE again. We have ILATE. What two expressions do we have here? We have x squared, which is algebraic, right? And we have e power 4x, which is exponential. Whatever comes on the left side, that is u. Whatever comes on the right side, that is dv over dx. So amongst these two, a is coming on the left, so that should be u. And e power that is coming on the right, that is dv over dx. So in ILATE, exponential is coming on the right side, algebraic is coming on the left side. So algebraic should be u and exponential should be dv over dx. So that's what we do here. We say x squared should be taken as u and e power 4x should be taken as dv over dx. All right, let's do this integration now. So integral of x squared into e raised to power 4x. This is what we want to evaluate. Let's write this down on the side. First of all, u is x squared and dv over dx is e raised to power 4x. Now we need to find du over dx. What's du over dx? That's 2 times x. And we also need to find v. That's the integral of this thing. It will be e raised to power 4x divided by 4. Now we have everything that we need. We just input those values in the formula and see what we get. U times v. What's u? U is x squared. Into v, v is this thing, which is e raised to power 4x divided by 4 minus integral of v, which is this thing, e power 4x divided by 4 into du over dx. What's du over dx? It's 2 times x into, with respect to x, that's what we have to do now. Outside, we have x squared into e raised to power 4x divided by 4. Inside the integral, we have e power 4x into 2x divided by 4. We could do some cancellation here. It becomes 2 here. We could write this 2 outside the integral. It's just being divided because this is minus 1 over 2. And inside the integral, now we have e power 4x multiplied by x with respect to x. And now we have a problem. We again have a product. Although it's simpler than the previous one. Earlier we had x squared into e power 4x, but now it's just x into e power 4x. It's simpler than before, but it's still a product. We would need to integrate this by parts again now. So we'll have to apply integration by parts on this once more. And that's what happens in the exam as well. You may have to integrate by parts. You may have to integrate by parts multiple times. Mostly 2, at max 2. You won't have to do it more than twice, but you do have to do it twice in a lot of cases. Okay, so this is one of those cases where you have to apply integration of parts once more on this. Now again, we have 2 expressions. One of them is algebraic, the other is exponential. So we use the same idea. The algebraic one should be taken as u, and the exponential one should be taken as dv over dx. Let's write that down on the side here again. U should be x and dv over dx here. And the second integration, that should be e power 4x. All right. Now, what's the derivative of u du over dx? That would be 1. Derivative is just 1. What about the integral of e power 4? That would be e power 4x divided by 4. All right. Now we input these values here again. Now outside this integral, we have the same thing as before. That will just stay as it is. x squared into e power 4x divided by 4, that stays as it is. We have minus 1 over 2, that also stays as it is. And now inside the brackets, we're going to apply that formula again. U into v, what's u? U is x here, into v, which is e raised to power 4x divided by 4, minus integral of v into du over dx. What's v? V is e raised to power 4x divided by 4 into du over dx, which is just 1 with respect to x. That's the integration that we have to do now. All right, let's simplify this. This gives us x squared e raised to power 4x divided by 4 minus 1 over 2 into x e raised to power 4x divided by 4 minus, you could write this 4 outside if you want. This becomes minus 1 over 4, and then you have to integrate e raised to power 4x with respect to x. That's what you have to integrate. Now this is a simple integral. There's no product in this anymore. You can integrate this directly. What's the integral of e power 4x? Integral of e power 4x would just be e power 4x divided by 4. That's the integration that you have for this now. So 1 over 4 remains as it is. The integral of e power 4x is e power 4x divided by 4. And that completes your integration. Now you could simplify this and add a c to the end, c at the end. Let's see what we get from that. That becomes x squared e raised to power 4x divided by 4 minus 1 over 8 into x e raised to power 4x. And you have this minus 1 over 2 and this minus 1 over 4, and also this 4. What is that going to give you? Plus 1 over 8 and 4. It's going to be plus 1 over 32 into e raised to power 4x. Then you have a plus c with that, and that completes your integration. So this is what can happen sometimes, that you have to use integration by parts twice. So you do it once, you still end up getting a product. So normally it happens when you have an x square. Okay. Why? Because when you differentiate x square once, it's going to give you x. So in the next integral, you're going to get x again. So you'll have to integrate by parts again once more. All right. So usually it happens with x square along with an exponential function, or sometimes with sine, cos, secant square as well. You have to integrate twice like this. All right. I hope that makes sense. Now, there are actually a few other cases of this that I want to discuss. But for today, we're going to stop here and we're going to continue with this in the next session. But before that, now you can actually try a lot of questions from the worksheet. So basically, in terms of concepts, you've done pretty much everything apart from substitution in P3 integration. Although there are some cases of integration by parts that I do want to discuss separately, which we will do in the next class, inshallah. But you can still try most of the questions from the worksheet. All right, so you should be able to do most of the questions from the worksheet now. Make sure that you try them. You have time now until Monday. Try to do as many as you can. And then we'll discuss some of those questions on Monday. On Monday, what we will do is we will complete the rest of the concepts, the rest of the examples that I want to do on integration by parts. That's one thing that we're going to do. And then we'll do some practice questions from the worksheet as well. And then on Tuesday, we will do integration by substitution. And on Wednesday, we'll do some more practice questions. Then we wrap this topic up. Okay. From next week, we are going to have more than 4 classes a week, inshallah. Most likely 5, or it might even be 6. Yeah, so it might even be 6 from the next week. My S1 course is ending in the coming week, inshallah. So I'll be starting M1 as well, but in order to finish P3 early, we are going to have more classes from next week, inshallah. Not this week, from next week, we will have at least 5 classes, maybe 6. All right, so we can speed up a little. We still have to do differential equations. In differential equations, iteration, and you have to do complex numbers and vectors, right? There are still 4 topics left after this, so we need to speed up a little. For that, we will do at least 5 classes from next week, inshallah, or maybe 6, so we can try to finish by the first week of April, inshallah. All right, that's it for today. I'll see you again on Monday. Make sure that you do practice questions. They're uploaded on Classroom. Questions are assigned as well. Start working on them. Uh, it's not going to be so all of that we've done in the last few days, even if you think you understand everything, it's not going to help if you don't do practice, because you'll forget all of this in a week and 10 days if you don't do it with your own hands. Okay, so make sure that you do practice questions, and then you can also come up with your questions. If you have any problems, discuss them with me, so that your concepts become clear. This is one of the hardest topics that you have in A-level maths. So you need to make sure that you do practice, okay, and do a lot of it. That's it then. I'll see you again on Monday. Unless you have any quick questions, in that case, you can ask them. Otherwise, we will end this class here.